faithfully delivering value by interpreting great books from around the world. Hi, this is Sally Book Talks. Today we're diving into the book called The History of Crazy Experiments. This book documents all sorts of bizarre scientific experiments from the 14th to the 21st century. To explore the unknown, those wild experimenters pretty much tried every trick in the book. Some fed spiders human urine, while others created dozens of live two-headed dogs. One guy lived on a scale for 30 years, another raised their kid with monkeys, and someone faked mental illness to sneak into an asylum. Why on earth would they do that? So, were these experiments even worth anything? Well, the answers are right here in today's book. The author, Swiss guy Reto Schneider, gathered tons of research on crazy experiments while working as a science reporter for media in Switzerland and Germany. But then his boss thought some stories were too old hat. Others just didn't make sense. So he refused to publish them in the paper. So he hopped over to the Zurich newspaper, started a column called Experiments, and finally got to share these amazing experiments with folks. Part of the stories in this book come straight from that column. When the German edition came out in 2005, it blew up right away and got translated into heaps of languages. The Chinese version went global in 2009 and has been reprinted 8 times since. All right, let's dive into those wild experiments from the book. I've split these experiments into 4 big groups based on what they're testing: non-living things, animals, other people, and the scientists themselves, even their kids. Picking off with the first group, inanimate objects like stinky socks. Back in the 1700s, folks knew rubbing stuff made static, but had no clue it was everywhere in daily life. A British scholar, Robert Simmer, noticed crackling noises when he pulled off his socks at night, and it hit him. Socks could create static too. He went out, bought every sock material he could find, mixed and matched them, and kept switching up how he wore and removed them. After doing this over and over, socking and unsocking thousands of times, Simmer figured out: wear 2 different socks on one foot, peel them off together, then snap them apart fast. Ah! This way produces the strongest electrostatic reaction. Among all sock materials, combining wool and silk socks gives the best effect. After that, he made his experimental findings public, along with as detailed a process as possible. First, he published his sock experiment in the most influential scientific journal of the time, the Philosophical Transactions. Later, he presented it 3 times at the Royal Society meetings, along with a 30-page report on the inspirations and reflections sparked by the experiment.
Later, he even gave live demonstrations at high society banquets.
Following Simmer's sock experiment, scientists began to deeply explore the factors affecting electrostatic generation. They gradually realized that the strength of static electricity from friction depends on the dielectric constant of materials, thus mastering the basic principle of triboelectricity. And if Simmer's unconventional electrical experiment only risked a bit of ridicule, then Galileo's thought experiment with 2 iron balls, father of modern physics, was downright audacious. Aristotle once said that if 2 iron balls of unequal weight are dropped from the same height, the heavier one will hit the ground faster than the lighter one. Until the 17th century, many still regarded his words as truth. But Galileo questioned it. If this is correct, then tying the 2 balls together should make their falling speed intermediate between them. But when tied together, the combined weight is heavier than either alone, so the speed should be faster than the fastest single ball's descent. Thus, Aristotle's law becomes self-contradictory. In this way, the young Galileo reached a groundbreaking conclusion purely through imagination. The falling speed of an object does not depend on its mass. As soon as this was stated, doubts and insults poured in, and it's rumored he was expelled from the University of Pisa, where he taught. Because this not only challenged Aristotle's authority and everyday experiences, but also seemed completely inconsistent. For example, in daily life, you see a stone fall faster than a leaf, and a hailstone fall faster than a snowflake. Of course, today's physics teachers explain that different falling speeds are due to varying air resistance. But back then, Galileo was seen as defying human truth. He couldn't be bothered to argue, just saying, if anyone still doubts it, go to the moon and try. On August 2nd, 1971, astronauts on the Apollo 15 spacecraft verified Galileo's assertion on the moon. They dropped a feather and a hammer, weighing 40 times the feather, from the same height simultaneously, and without air resistance, both landed on the lunar surface at the same time. As media reports at the time said, even though the result was predictable before the test, the actual outcome was even more reassuring. Galileo's wild assertion was finally settled nearly 400 years later. For studying physics problems like electricity and mechanics, experimenters can use inanimate objects. But for biology, medicine, and other fields, they need to use living things. For example, using animals in experiments, that's the second category of experimental subjects we're going to discuss. That was for, first, let's talk about invertebrates, like spiders. Scientists love using spiders in experiments because they have a unique ability: weaving webs. Scientists explore factors influencing biological behavior by observing the webs spiders weave. In 1948, there was a young assistant professor named Peter Witt in the pharmacy department at the University of Tübingen in America. He wanted to quantify the effects of various stimulants through spider webs. So he fed experimental spiders all the stimulants he could find, from caffeine, morphine, marijuana, to potent hallucinogens like LSD, one by one. Then he observed the differences in the webs they wove before and after getting high. Witt found that under caffeine, spiders wove the most chaotic webs. Under marijuana, the webs were the most beautiful. And under the strongest hallucinogen LSD, the webs turned out to be the most regular. But in the end, because the data analysis was too difficult, the goal of quantifying drug effects using spider webs wasn't achieved. In the early 1950s, biologist Peter Reed's research team also tried to uncover the secret of schizophrenia using spiders. And compared to stimulants, what they fed the spiders was even weirder: urine from schizophrenia patients. They speculated that there was a substance in the urine of schizophrenia patients that caused the schizophrenia. Although this experiment didn't yield any valuable conclusions in the end, but one thing is certain: for spiders, human urine is definitely not a tasty treat. After drinking a little urine, they quickly left the web, shook off the remaining urine, and only returned to the web after cleaning it and their mouths thoroughly, never touching it again. And so,
The newly placed urine.
compared to invertebrates like spiders, more experiments use higher vertebrates as subjects, such as dogs. In 1954, Soviet surgeon Vladimir Demikhov performed a bizarre surgery for organ transplant research. He severed a puppy's head with its front legs, attached it to an adult wolfhound, connected their arteries, veins, trachea, and esophagus, while the wolfhound's own head remained intact. Thus, a grotesque two-headed dog was born, the world's first full-body part transplant. 3 hours post-transplant, the wolfhound woke. A day later, the attached puppy head showed signs of life. It even bit a researcher's finger until bleeding. This two-headed creature died of infection 6 days later. But Demikhov persisted, performing 20 such surgeries over subsequent years.
Once he transplanted an entire puppy onto a female dog's neck. The longest surviving two-headed dog lived 29 days.
Though controversial, these experiments earned Demikhov global renown. After the USSR launched Sputnik in 1957, Demikhov's work was hailed as the Sputnik of surgical medicine. This wasn't medicine's first fascination with dog heads. Back in 1928, Russian surgeons Sergei Brukhonenko and Chechelin began experimenting on severed dog heads. Before crowds, they decapitated dogs and connected the heads to artificial hearts to sustain life. Witnesses saw the heads' pupils contract under flashlights. Vinegar smeared on their mouths was promptly licked off. Bitter quinine made them shed tears. Fed candy was swallowed but rolled back from the esophagus. Popular science magazine, Science and Creation, condemned this as cruel and inhuman, yet marveled that even sci-fi writers' wildest fantasies pale before science's relentless advance. Beyond dogs, even bulls from bullfighting rings drew scientists' morbid curiosity. One day in 1963, a peculiar bullfight unfolded on a small farm in Córdoba, Spain. The bullfighter was Spanish neuroscientist José Delgado, dressed in a suit. Holding a red cloth in his right hand, he slowly approached a star bull named Lucero. Yet soon the bull became enraged and charged wildly toward him. Just as Delgado was about to be attacked, the bull suddenly stopped and casually wandered away, as if nothing happened. The secret behind this dramatic scene was the remote control in Delgado's left hand. He had previously implanted wireless electrodes in the bull's brain. When the bull charged at him, he pressed a button on the remote. The chip activated, sending 1 milliamp of AC current through the bull's brain, temporarily eliminating its aggression and making it docile. Reactions to this experiment were intense, with fears that humans could be completely controlled, but Delgado dismissed these concerns. He believed electrical stimulation could make humans happier and more peaceful, potentially creating a new, psychologically civilized society. While Delgado's vision remains unrealized, electrical stimulation is now used therapeutically for neurological disorders like epilepsy, rabies, and Parkinson's, and as adjunct treatment for severe depression and OCD. Among experimental animals, monkeys share the closest kinship with humans, making them ideal subjects for studying human emotions. In 1958, a monkey experiment caused huge controversy, designed by American psychologist Harry Harlow. Harlow's research focused on infant monkeys' attachment to their mothers. Harlow separated newborn monkeys from their mothers and provided 2 surrogate mothers, one made of soft wool padding, the other a wire frame with a milk bottle attached to its chest. The baby monkeys clung tightly to the cloth mother for over 12 hours daily. They only climbed onto the wire mother when hungry. Later, Harlow created several monster mothers, soft-textured but equipped with mechanisms to frighten or harm the infants. Surprisingly, the infants remained attached. Whenever the monster mother calmed, they'd immediately return and snuggle closely against her. Harlow thus proved that infants' attachment to their mothers is a biological instinct, unrelated to whether they provide food. In reality, animal experiments often occur because scientists can't conduct them on humans. For the third category, let's discuss those crazy experiments researchers conducted using humans. Some experiments used people who were already deceased or nearing death. For example, in 1901, an American doctor named Duncan McDougall wanted to weigh the human soul, using terminally ill patients as subjects. McDougall's logic was, if the soul exists, it must occupy some weight within a living body. After physical death, the soul would leave the body, so measuring weight change at death could reveal the soul's weight. For this, he built a special balance bed, and the first dying patient was placed on this soul scale. 3 hours and 40 minutes later, he drew his last breath. At the moment of death, the scale's indicator shifted noticeably, lighter by 21 grams, though this result never reappeared in 5 subsequent experiments. And yet for over a century, the 21-gram soul theory has endured in popular culture. In 2003, this experiment was adapted for the big screen. The film about life and death was titled 21 Grams. Besides dying patients, executed prisoners' bodies often became scientific subjects. For instance, since the guillotine's introduction in France in 1891, scientists wondered how long a severed head could survive, trying methods like slapping the head, shouting insults, or calling the name while awaiting responses. In 1885, a French doctor even connected a freshly severed head to a dog's circulatory system to see if it could revive. Regrettably, after these chilling experiments, scientists still couldn't determine how long a severed head could survive independently. Compared to the dead, experiments on living humans are undoubtedly harder to accept. In 1822, Canadian soldier Saint Martin suffered an accidental gunshot to the abdomen, causing a stomach perforation. Strangely, after his wound healed, it left a visible hole through which a hand could easily reach in and touch his stomach lining. St. Martin's unique condition caught the attention of an army surgeon named William Beaumont. Back then, little was known about food digestion. Beaumont had long wanted to study the digestive process, and he quickly convinced St. Martin to begin a series of remarkable experiments. In one experiment, the doctor tied small pieces of beef, lard, bread, and cabbage with silk thread, inserted them through the hole into St. Martin's stomach, then pulled them out an hour later to observe digestion. In another, he inserted a tube through the hole to extract gastric juice, then placed a beef particle in it to observe the digestion process. These experiments quickly yielded important conclusions. For example, gastric juice is key to digestion, and different foods require varying digestion times. Beyond individual cases, most human experiments require recruiting groups of volunteers. On a summer night in 1955, Utah's Dugway Proving Ground prepared to conduct a biological weapons test on human subjects.
They used Q fever pathogen, a bacterium causing severe headaches and muscle pain.
With a 130 mortality rate, using humans as medical subjects wasn't uncommon. All medications must undergo clinical trials before use. But this Q fever experiment wasn't meant to cure, quite the opposite. It aimed to infect people. The 30 volunteers belonged to a religious group called Christ in the Wilderness. They were chosen because members didn't smoke or drink. Many were vegetarians, giving them robust health. This helped eliminate confounding factors in disease and infection experiments. The sect embraced the government's proposal, believing they'd contribute to national health and security. With a whistle blast, a solution filled with Q fever pathogens sprayed into the night sky. The 30 chosen volunteers stood in the pathogen mist, undergoing physical and spiritual baptism. After returning from the Utah desert, about 1/3 of the volunteers fell ill. Fortunately, everyone eventually recovered.
Beyond viral infections, in the early 1960s, scientists testing hallucinogens openly gave drugs to volunteers.
Today, such experiments rarely get approval. They cross legal or ethical lines and cause too much harm. Other experiments posed greater psychological challenges without physical harm. For instance, a controversial infamous one psychology experiment. Designed by Stanley Milgram, a young Yale assistant professor, he tested how authority pressure affects personal behavior. 2 volunteers played teacher and learner. The teacher quizzed the learner, whose hand was wired to electrodes.
Wrong answers meant the teacher pressed a switch to shock the learner.
Starting at 15 volts, increasing by 15 volts each time. Unbeknownst to teachers, the learner was an actor faking shock reactions.
As voltage increased, the actor progressed from complaints to screams, refusal, rage, then silence. During fake unconsciousness, anxious teachers repeatedly asked the supervisor, seen as scientific authority,
"Should we continue?" After hearing yes, 2/3 continued to press the maximum 450-volt lethal switch. Over 1,000 volunteers participated. Volunteers included factory workers, welders, nurses, housewives, ordinary people without inherent aggression. Many sweated nervously or argued, but few stopped. Defying authority proved so hard they abandoned basic morality. Milgram concluded we all harbor innate obedience, likely enabling Nazi atrocities in World War II. This experimental result reveals disturbing aspects of human nature, sparking intense controversy. Since then, All universities have implemented new ethical requirements for conducting experiments. The experiment's designer, Milgram, consequently ruined his career. He died despondent at age 51. The fourth and final category of experiments. Their subjects were unique. The researchers themselves, even their children. Some experiments studied the human body and diseases. For example, in the early 17th century, Dr. Santorio lived on a scale for 30 years to study human vital activities. He connected his desk, chair, bed, and instruments via ropes to a ceiling balance, meticulously recording bodily changes for 3 decades. From food intake to excrement weight, nothing was too trivial. Thus, Santorio became the pioneer of quantitative experimental medicine. Scale life required patience but was at least safe. Some scientists risked their own safety for experiments. In 1968, American veterinarian Lopez wondered if cat ear mites could infect humans. He inserted about 1 gram of mite-infested cat earwax into his left ear. After 3 weeks of unbearable itching and pain, he nearly lost hearing in that ear. But the suffering didn't extinguish Lopez's fervor. For reproducibility after recovery, he repeated the experiment twice more. Cat mites repeatedly infected his left ear. But symptoms lessened each time. Lopez guessed the first trial gave him immunity. This confirmed cat ear mites can infect humans. Many scientists like Lopez have subjected themselves to extreme experiments. In 1984, Australian doctor Barry Marshall collected bacteria from a gastritis patient's stomach, mixed it with water, and drank it. Well, Marshall's only wish was for the bacteria to make him sick. It was Helicobacter pylori, later proven to cause gastritis. But back then, this bacterium was unknown. Stomach ailments were blamed on stress and emotions. Marshall accidentally discovered this unknown bacteria in a gastritis patient's stomach cells, speculating it might cause gastritis. To verify this, he needed to prove the bacteria could infect lab animals. But experiments with rats and piglets all failed, so he decided to test on himself. Before this, he'd just had a gastroscopy showing his stomach was healthy. After drinking the bacterial solution, Marshall suffered vomiting, halitosis, headaches, and other discomforts. On day 10, a colleague took a stomach sample. Marshall excitedly discovered he'd developed gastritis with the same bacteria he'd swallowed. The conclusion was undeniable. This bacterium causes gastritis. In 2005, Marshall won the Nobel Prize for this. Dubbed the doctor who experimented on himself, he made newspaper celebrity columns. Both Lopez and Marshall were fortunate. The experiments caused no lasting harm. They fully recovered. But such reckless attempts don't always end well. As the author states in the preface, real-world experiments are like warfare. Once engaged, all plans vanish. In 1928, American doctor Egon Berger injected 0.2 milliliters of diluted black mamba venom, the world's deadliest snake venom, into his forearm to study its effects. No, but Egenberger underestimated its potency. The venom spread rapidly through his body, with symptoms far exceeding expectations. Had he not reacted swiftly, Egenberger would have paid for his recklessness with his life. Scientific history is filled with researchers who risked everything for knowledge. Sally Book Talks once covered Smoke Gets in Your Eyes and Screaming Teeth, chronicling scientists who experimented on themselves. Other experiments study consciousness and mind, less physically harmful but potentially mentally destabilizing. In 1954, John Lilly, American triple PhD in biology, physics, and medicine, began researching the human brain. His question, how would the brain react when all external stimuli are blocked? He built a massive isolation tank inside a pitch-black, completely soundproofed room, essentially a giant bathtub filled with regularly refreshed warm water. Subjects would float submerged on their backs, connected to the outside via a comfortable breathing mask. This design minimized all external stimuli, including gravity, to near imperceptible levels. With such bizarre experimental conditions, finding volunteers proved impossible. So Lilly decided to test it himself. He climbed into the tub, sank underwater, and lay motionless in absolute darkness. He barely moved, even urinating in the water, only emerging occasionally to eat and stretch. After living underwater for a year, Lilly concluded that after about 2.5 hours without external stimuli, the human brain starts hallucinating. Strange glowing shapes appear at the edges of vision, even a shimmering blue tunnel. But these were just personal experiences, hardly valuable scientific conclusions. People suspected Lilly might have gone insane after a year of isolation. Was he actually crazy? Hard to say. Sometimes the line between sanity and madness isn't so clear-cut. In 1968, Stanford psychology professor David Rosenhan wanted to determine if there is a clear distinction between the mentally ill and the sane, and whether people can accurately tell them apart. He believed answering this required testing whether a psychologically healthy person could be recognized as sane inside a psychiatric hospital. Could they be identified as mentally sound within such an institution? So Rosenhan and 7 other researchers began their own One Flew Over the Cuckoo's Nest-style adventure. From 1968 to 1972, using fake names and fabricated symptoms, they infiltrated 12 psychiatric hospitals. Their shared mission: convince hospital staff they were psychologically healthy to secure their release. Initially, all fake patients feared quick exposure. They meticulously kept experiment logs and smuggled materials with extreme caution. But they soon realized this was unnecessary. Hospital staff paid zero attention. When one pseudo-patient wrote observations, nurses simply noted, "Patient maintains writing behavior." In the end, none of the fake patients were exposed. Most were released only after being diagnosed with mild schizophrenia 3 weeks later. I think the worst, Rosenhan once waited a grueling 52 days to be released. In his experiment log, Rosenhan wrote, "These supposedly professional medical staff showed little ability to distinguish the mentally ill, revealing biases in their thinking, faithfully delivering value by interpreting great books from around the world." Hi, this is Sally Book Talks. Today, we're diving into the book called The History of Crazy Experiments. This book documents all sorts of bizarre scientific experiments from the 14th to the 21st century. To explore the unknown, those wild experimenters pretty much tried every trick in the book. Some fed spiders human urine, while others created dozens of live two-headed dogs. One guy lived on a scale for 30 years. Another raised their kid with monkeys, and someone faked mental illness to sneak into an asylum. Why on earth would they do that? Why? Oh, so were these experiments even worth anything? Well, the answers are right here in today's book. The author, Swiss national Reto Schneider, gathered tons of research on crazy experiments while working as a science reporter for media in Switzerland and Germany. But then his boss thought some stories were too old hat, others just didn't make sense, so he refused to publish them in the paper. So he hopped over to the Zurich newspaper, started a column called Experiments, and finally got to share these amazing experiments with folks. Part of the stories in this book come straight from that column. And when the German edition came out in 2005, it blew up right away and got translated into heaps of languages. The Chinese version went global in 2009 and has been reprinted 8 times since. All right, let's dive into those wild experiments from the book. I've split these experiments into 4 big groups based on what they're testing: non-living things, animals, other people, and the scientists themselves, even their kids. Kicking off with the first group, inanimate objects, like stinky socks. Back in the 1700s, folks knew rubbing stuff made static, but had no clue it was everywhere in daily life. A British scholar, Robert Simmer, noticed crackling noises when he pulled off his socks at night, and it hit him. Socks could create static too. He bought every sock material available on the market, tried them all, mixed and matched them arbitrarily, and kept switching how he wore and removed them. After doing this repeatedly, socking and unsocking thousands of times, Simmer discovered that wearing two different socks on one foot, peeling them off together, then snapping them apart fast, produced the strongest electrostatic reaction. Among all materials, wool and silk socks combined gave the best effect. After that, he made his experimental findings public, along with the most detailed process possible. First, he published his sock experiment in the era's most influential journal, Philosophical Transactions. Later, he presented it 3 times at Royal Society meetings, plus a 30-page report on insights and reflections.